Hello? Oh, cool. All right, so I'm Lilith. I'm from Talos. Yeah, I think that's a good start. I did a project with a partner of mine on our team studying the Disney Circle. It is a device that is used to protect your children. Potentially, ironically. So yeah, I guess let's start. So more specifically, I'm a researcher on the vulnerability development team for Talos. We are a Cisco Talos, so we fuzz, we reverse, we read manuals, we just essentially pick something and find as many bugs in it as possible. And it's fun, you know, we just break shit. So we find 0 days in third-party software. We do not touch Cisco products. We submit the bugs to the vendors, privately, of course, responsibly, of course. And then we get them fixed. And then we post the bugs on our blog, and it's cool. Oh man, I remembered my joke I was going to use for an introduction. I'm glad so many people survived last night's festivities. It was okay. But yeah, so I'm the youngest one on my team, so if you don't like the presentation, that's my excuse. And I'm very thankful to have such a experienced and smart team. Like, they're just brilliant. So more specifically, this is not updated. But we're missing some people on this list, but this is everyone. We've hit stuff in Microsoft, Apple, Oracle, basically everything. I've done stuff in VMware, Zabbix, Monero, but anyways. So yeah, and one last shout out before we begin to Claudio Bizzato. He's actually my like team lead now, which makes this kind of awkward because we worked as like equals on this. And I'm like, man, where's my team lead thing? But yeah, without him, and he's our embedded person, although he might be angry if I say that. But he's brilliant, and we could not have done this without him. So thank you, Claudio. Thank you for the free presentation tour. So yeah. IoT. So I'm lazy. I don't like to I like to source my quotes too. So I'm actually quoting a quote by ZDNet about Cisco. There's just going to be a lot of IoT devices. I mean, we see them everywhere. But like for each person, we're going to have, I don't know, probably a few, based on the numbers, probably like 3 IoT devices per person. You know, your Alexa for your bathroom, your Alexa for your bedroom, you know, Alexa for your garage and your attic. But yeah, there's going to be a lot of projected devices in the future. So this is why we sort of wanted to target it, is because IoT is a very fresh field right now. It's very young, I suppose, and the devices are not as hardened as your current 64-bit Windows implementations, sort of. But yeah, so what is an IoT device? Hey, it's typically a 32-bit or 64-bit ARM or MIPS. 32-bit is much more common. I've only seen, personally, one 64-bit machine because, I don't know, maybe the processors are probably more expensive. It's more often, it's like a 50-50 split between ARM and MIPS, though. They have external sensors, obviously, so they can interact with the outside world. And they generally talk to other things in close proximity, whether through Wi-Fi, Zigbee, or Bluetooth. So, or QR codes. Yeah, anyways. But yeah, there's also a lot of other commonalities between IoT devices, like they're crap. Asynchronous communications, like, oh hey, you know, I can control my smartphone from the stage right now. I mean, it's cool, but it's not the best for security. Lack of firmware updates are another huge thing. It's expensive to have a way to push out updates. It's just like the old school embedded phones. Like, the stuff just doesn't get updated because there's no good way really to do it or established method. People just roll their own solution, which always ends up messing up. Auto configuration / ease of setup is typically a thing we hit too, because IoT devices are all usually aimed towards, you know, grandma, grandpa. They're not marketed towards the tech-savvy people, because you just want to be able to plug and play, and that, once again, lends itself to abuse and exposed network ports and buggy code, but that's all things, right? And yeah. So, another case in point about IoT, if y'all have ever heard of this, it's a sort of famous thing. Internet chemotherapy. A dude, Dr. Cyborgian, he wrote the BruCON and ended up breaking like 3 million devices because it was just basic creds. You could just log in over the network, default credentials, boom, and brick it. And I mean, better for it to be bricked, at least in my opinion. Oh, I should say before this, the Cisco's, or the opinions said today are mine and not Cisco's, not my company's anything. I say dumb stuff. I'm not representing the company when I say those things. So yeah, I think it's honestly a good thing that the BruCON happened because rather these devices are bricked than host to some new botnet. But yeah, anyways. So a quick look at doing it right and doing it wrong. So this is the FalseCam. Well, FalseCam is a brand. This is one of their products. IP security camera, easy peasy. So essentially, Claudio, the guy I mentioned earlier, my BFF, he looked at this thing, and those are all the vulns he found. So, like, I mean, all of those are pretty much remote code execution. Just boom, root. In 30 different ways. Like, it's almost pitiful because you don't even need that many different types of root. You just need one, right? But this is doing it wrong, most definitely. And we released all these were patched and so forth because we are responsible. But like, if this is what we found in one product, like all you need is one, right? So doing it right, honestly though, I've taken a look at the Amazon Key, the Cloud Cam, and like we couldn't find anything. They did it right. There's a lot of cool things that it did. I wish a lot of IoT devices would adopt, like, I sort of wish there was, I hate saying this, I wish there was a standard, because there's a lot of standards. But, like, for updates, like, you cannot talk to the camera itself. The camera only talks outbound. And that, just in itself, all the connections outbound are encrypted. You cannot connect to it. The only time you can ever connect to it is with Bluetooth during setup. And past that, there's nothing. And so, like, somebody should write an RFC or something. But yeah, there was a CVE phone found in it a long time ago. A long time ago, maybe like 2 years ago. But essentially, you had to be like in the proximity of the device, like in the physical area, when a delivery man remotely opened the door. And I mean, a bug's a bug, but it's not RCE. So, anyways, so on point, the case study for today is this thing, the Disney circle. It's not even a circle. That's the first joke that worked. God damn it. So it's got a circle on it. Let's be fair. Do you see that? I hope the cameras can see this. But yeah, so like I was mentioning earlier, you essentially allow your parent to monitor or restrict what the kids are doing. You can base it off of age groups. You can be like, oh, my kid's 3 years old. I don't want him doing anything besides Disney. The funny thing is, one of the funny things, is how it actually did it is immediately when you plugged into your network, it would just ARP poison the entire network, which I thought was funny when I saw it. I was like, no way, I can't believe it, because they were actually taking like an attacker technique and utilizing it for something else. Refreshing. So yeah, there are a couple of other things it would do actually, is that when your kid would look up a DNS name, it would actually query out to BluCON, if any of you are familiar with them. They do a lot of like DNS name filtering remotely. So it would query outbound to these servers and be like, okay, if it wasn't a URL that was in the included embedded list, it would query outbound, be like, oh, that's a bad site, don't go there, and it wouldn't. But yeah. Yeah, don't put this thing on your network if you have something else that does like security. It actually doesn't work with a lot of routers just due to the fact that ARP poisons everything. So, cool fact of the day. But yeah, so this is everything we found in it. 23 vulns, I believe. Not all of them are RCE, admittedly. But yeah, we found quite a few bugs in it, and which is ironic because like it's supposed to make your kids safe. But it did kind of the opposite. So I'm not going to cover all these because it's too much work and I'm lazy. And we don't have enough time. So we are going to cover, obligatory pie chart before I go on. So that's the basic breakdown. There's a lot of command injection, memory management a little bit. I don't even know why I have this because half the graph is MISC, which doesn't give you any information. But yeah, like I was saying, we're not going to cover everything. We're only going to cover these ones in 4 groups. Because they're the interesting ones, in my opinion. Interesting or funny. Yeah. So, bug number 1. Use after realloc. How many people are familiar with like use after free vulnerabilities? The classic bug class, one of my favorites. Okay, we got a fair amount. So I'm gonna go sort of in depth and try to start higher level though. So the reason I'm mentioning it is because there's, I guess, a lesser known cousin to the use after free, the use after realloc. As the name implies, we're allocating memory on the heap, and then we're getting rid of it, and we're putting something else there, and then something bad happens. A quick refresher on Linux memory layouts. Stack grows up, heap grows down. Anyone who says the reverse is wrong. Shared libraries in the middle of that, and then I don't know. There's not much to really say for the rest of it so far. But we will get more into the heap specifically because that's what this basically in this entire bug is about. But yeah, what the heap does essentially, I'm zooming in on that, it grows in one direction and it actually has certain slots. Based on the size of the allocation, the memory allocated can be in different spots. So if like you keep, imagine this is the heap, it's a great example. So you keep placing it, but if you got a heap chunk that's too big, it goes up there instead, and there's a gap in between, free space. So that's actually going to be kind of important later. So I hope you're taking notes. Oh, and one last thing. What a big allocation is, quote unquote, depends entirely upon the heap implementation. So it could be UC libc, it could be DL malloc, which is a classic. It could be, in fact, DL malloc, like different versions will do things differently. Or it could be Windows heap, it could be segment heap nowadays. But anyways, boop. So, at least in Linux, there's 4 main methods that are used for controlling heap chunks. Malloc, which gives you a chunk of memory. Calloc, which does exactly the same thing, except clears the memory too. Free, which throws the memory back to the computer, so it can do whatever it wants with it. And we got realloc, which is what we're going to be talking about. And not many people, like, if you've done malloc and free and stuff like that before, nobody talks about realloc for some reason. And I honestly sort of don't know why it exists as a function, because the same goddamn thing is doing like another malloc, mem copying everything over, and then freeing the old chunk. But it's the implementation is actually kind of hilarious because based on the parameters, it can do different things. But we're going to talk about that. So just a really quick example. If I do a size 0x20 allocation, and then I realloc a second chunk, all it does is it makes the second chunk bigger. Easy? Are we following? All right. So interesting things is that if the second parameter to realloc is 0, it actually frees the chunk instead. Which, if it's a user-controlled size, that's really bad. You need to check that stuff. Another interesting thing is that if the first parameter is empty, it allocates a chunk. And if they're both null, it actually allocates a 0x8 size chunk. But that's just Linux in general. If you do a size 0 allocation, it still generally allocates something. Anyways. The funniest thing about realloc is that the pointer you pass in to be realloced may not point to the same place afterwards. And that is really key. So it's not like you give it a pointer and the pointer changes value. No, it returns a new pointer that you need to use because in certain situations, the chunk of memory actually moves. It doesn't get expanded like that. It actually shifts location, which is what the UAF stuff is going to be about. So if you realloc it to a really big size, it's going to put it into the M break spot in memory, where the really, really, really large chunks go, because the heap is not big enough to contain such a chunk. But yeah, so like I was saying, there's a couple situations that can actually cause this underlying memory shift. The first situation is like I was saying before, you allocate a stupidly huge chunk for some reason. Excuse me. That's monster for you. But so yeah, that's the first situation. I mean, as you expect, like I was saying, the computer actually has to go through and be like, I need more memory for my heap. I'm not just going to allocate a new chunk. Like, the total size of the heap is not big enough. So, anyways, and there's a separate syscall for that. The second situation, actually, the more interesting one for my exploitation situation, is the fact that if you don't have enough space to expand, it actually shifts memory. So as you can see from the second example, I have two size 0x20 chunks that are going to be consecutive. And I'm not going to get into buckets right now or anything like that, or the underlying implementation. I'm just simplifying this. So there are two chunks of memory, right next to each other, and then another chunk that's actually freed up, or further up. Now, there could be a little bit of memory in between, just because like fragmentation and so forth. Oh, I had a size 3.0, then I freed it, and then I allocated a 2.0, and now it's there. But that's just how up to heap implementation again. But keeping it simple, if I reallocate chunk 2 to be size 6.0, it obviously cannot go over, it cannot overwrite chunk 3. So the pointer in memory points to a new spot, which is going to be further down the heap. But yeah, so why is this an issue? So if I have a variable, and this is an example for a reason. If I have a variable that's like output stir, and it points to a piece of memory that I can reallocate as many times as I want, what happens if it gets assigned to my original memory? I reallocate it, shifts memory, and now I've got a dangling pointer. That's bad, yo. So it does lead to a classic UAF situation. If the user can control the size of the allocation of the realloc, and you do not check or you do not assign correctly, you don't move all your pointers also. So there was that situation in the APID web server on this thing. So port 80, unauthenticated. What ended up happening? I could just connect to it, send a really specific response, and then I could dump strings out of their private user cred database, so inside of the access control allow origin field. So it was actually a really tight constriction, and because just due to how the server worked, there weren't really much that you could dump until I realized, oh, it's not only using mallocs, it's also using C++ mallocs, which is a really weird name in IDA, like ZWN or something. But anyways, yeah, so that was kind of a deal. Included in that was phone numbers, addresses, emails, I think a password? I can't remember. But yeah, so that's not cool. So yeah, that's the most technical bug for today. I wanted to get that out of the way just because everyone, get your energy out of the way now, and now we just get to laugh. So yeah, SSL attribute parsing. Who's excited? No, a few? Okay. So they home rolled their own crypto to some extent. They had I'm just going to keep going. we pwned their SSL attribute parsing. Yeah, so this is their domain name. It was meetcircle.com. I can't believe I found that picture. It makes me slightly uncomfortable, but that's the best representation that I could find. This is my favorite joke of the presentation. I actually added this specifically for the Cisco people, but I thought you would like it too. Anyways, so yeah, what ended up actually happening? I'm going to be saying that a lot too, so get your Snickers out of the way now. But yeah, so the function that they used to actually parse the information out of the certificate was this one here, 8509 name one line. It is actually a deprecated function within the OpenSSL library. Deprecated for a damn good reason. So as you can see by the example at the bottom, if you run that function on a given certificate, you will get the output at the bottom. And one string, it's a null terminated C string, okay? So yeah, Yeah, interestingly enough, depending on the input size, like the memory can actually be on the stack or dynamically allocated, which I find to be kind of funny too. But anyways, but yeah, TLDR, don't use this function if you're into that sort of thing. I wouldn't expect most people to be. But yeah, so into the actual certification verification code, that kind of rhymed. We jump to the X file one line here. We get that string back that I told you about earlier. It's got all the attributes on one line, the CN, the DN, the OU, whatever's in it. And after that, it does a stir check for the star.meetcircle.com domain. And so if you're not familiar with stir, it is a function call that takes two strings, and if it finds the needle inside of the haystack, it will return a pointer to the location of the match. And if it doesn't, it returns 0. So it's just doing, hey, do I have meetcircle.com inside on my certificate? And if we don't, it's an invalid certificate. I mean, it makes sense, right? But, oh, I guess I just talked over all that. Cool. Yeah, so easy peasy, right? So back to our example, if I have a certificate that is designated for the boopdoop.net domain, it will not work because the string doesn't match, right? It's pretty obvious. But so like the funny thing about certificates is like you can generate a certificate, like any certificate you want. You can do anything you want. It's just a file, right? The hard part is getting somebody to sign it because SSL, that's just how it works. The companies are trusted. They will only sign valid certificates, quote unquote. But so there are funny things you can actually do to something like this. There is an awesome example of a MongoDB vulnerability that was exploited at the bottom there, that link. But essentially, it's essentially the same thing we're going to go over right now. So you can create another certificate with another attribute that actually does the substring match. So instead of saying my domain is star.meetcircle.com, I'm going to say my organization is cn.star.meetcircle.com. And it's a funny ass vuln because it's so simple. But like, I mean, if it's dumb and it works, it ain't dumb, right? So yeah, so this actually didn't work on the circle. We had to be a little more creative because they did cert pinning. Depending on the daemon, there is a hard-coded Komodo and Entrust, those are the company's certificates for SSL. And if you don't know what cert pinning is, it is essentially a hard-coded certificate. I don't know why they give it such a fancy name, but yeah. So we couldn't do this tech because Entrust and Komodo are not going to sign something like that. And if they do, they generally overwrite all the other attributes, like with, hey, this was signed by Komodo. So that way you can't even get away with something like this. So we had to be a little creative. So we've established that, that's not going to match, right? And no CA is going to sign something with the OU equal to a domain. But, doop-a-doo, what if we get somebody to sign that? Meetcircle.company. I'd like to call it the TLD extension attack because I love fancy names. But yeah, like nowadays there's a goddamn domain for everything, like .ninja, company and computer, and .dog. I don't fucking know. Yeah, you can seriously, if it's doing just a string match, just extend it to some other one. And those are seriously valid domains. We registered them. We got them signed, and we could successfully intercept SSL communications between the R client, the Go client, and the libBlueCoat SSL verification. So we got 3 different SSL connections we could man in the middle, which is kind of a big deal considering what was thrown over there. Yeah, and like I said, these aren't the most sophisticated attacks, but it's, A, I put them in because I think they're kind of funny, and B, they're not really that funny when you realize what's actually being sent over those links. libBlueCoat, BlueCoat, like I mentioned before, was actually used to check DNS names that weren't in the hard-coded DNS names. So like every domain name that your kid looks up is going to be sent, you know, to the libBlueCoat servers. And that can be abused in a few ways. That you know, obvious malware domain is now valid, you know, stuff like that. Also, one of the things that happened is immediately I'll talk about more about this later, but like your administrator credentials got sent over the our client link immediately on first connection. So it's just like if you could intercept the SSL connection, you could automatically get root on it. So it's still kind of a deal, even though it's funny as shit. So yeah, the next class of bugs, I'm going to talk about some Wi-Fi SSID stuff. So why mention it? Because I like war driving, and well, I don't actually do it, but it's a cool idea. And I think it's going to make a comeback. Just driving by a neighborhood and like pounding devices just by like broadcasting an SSID. The future is going to be great. So the first one I'm going to talk about is the insecure access point setup vulnerability, which came into being mainly because, like I mentioned earlier, these devices are geared towards more casual people. I say casual because I game and I'm like, you know, filthy casuals. But so yeah, not, like I said, grandma and grandma, not your average techie. So you seriously just plug it and it plays. In the case of the Disney Circle, though, like they want to make it as easy to set up as possible. So they don't want you to configure like security options for your Wi-Fi or anything like that. They just want to be, hey, what's my SSID? What's my password? Oh, I connect. Cool. You know, it's that easy, or it should be. The unfortunate thing, though, is if the Circle got disconnected, it would try to reconnect to the same SSID. And it wouldn't actually check to see that the password was there, or that it was the same, or that it even cared about a password. So we could just de-auth the device from any given network and then pop it onto our network, which is kind of a bad thing. Because then, once we have it on our network, we pwn it, we drop it off our network and throw it back on the home network. And we have a beacon inside of a home network, because it's automatically going to reconnect to their stuff. Or actually, I think we could also pull the SSID password out of it. So either way. So, I mean, that's not really that big of a deal. Yeah, you get a free Circle. But what happens now? We can get shells through Wi-Fi shenanigans also. I'm going to give credit to Claudio here, where credit is due. He is the one who did this. I think we were working on it together, and then I'm like, oh, this is going to be too, you know, I'm going to look at something else. But essentially, we could end up broadcasting a specific SSID and get code execution. So I don't know. I like really novel attack vectors, and I think this stuff is really cool. So the thing that we, I guess, ended up doing is that assume we pop it off their network onto, or we have admin creds. Maybe it's just a local route, whatever. So assuming that there's no SSID configured, we broadcast our own. And as you can see here, this colored thing here, the encryption, we actually have a command injection, easy peasy. I mean, it's rather simple to understand. It's just quotes some, you know, NC, which is netcat, right? And then a star. So the reason why I mention this, and again more specifically, is before I go on further, there's a few like restrictions, especially for SSIDs. An SSID can only be 32 bytes long. That is thing number one. And because of this, we are limited in what payload we could use. Thing number two, we had to match certain things to even get to the command injection. So we start off with 32, and then due to how the programs would parse the SSID, so like you connect your phone, right, or you want to connect to your phone, it would list out all the SSIDs, right? And this is the code we were injecting into, where it's just like, which one's your home network? And then like we connect to it, right? So, yeah, so like we had to bypass their filtering, I guess, so that it was parsed validly to get even our bytes in there. And due to the fact that we had a restriction not only on the length, but also on the fact that we needed to pass validation, our payload was only gonna be 4 bytes to work with. We had a 4-byte command injection. And Claudio, doing the magic that he does, managed to get command execution with that string there. So the entire string eventually gets parsed to a script, as you can see at the bottom, and that's why we have extra quotes and the semicolon was to bypass that part there and have it actually run. But like NC star doesn't make sense, right? That normally would not run. But we got lucky in a couple aspects that I thought was hilarious too. So yeah, due to the directory it was running in, when you glob on Linux, it lists all the files. There's 2 files in the directory. One of them was called run, and one of them was called supervise, because that's how all of the services were running on the device. So when you did nc star, I mean, it globbed out to nc run supervise. And if you know the syntax for netcat, it's, host port. So what does nc do at this point when it's got words instead of numbers? It tries to resolve run, and if we control the local network and we say that run is me, it points it to me, which is great, because now the NC is pointed towards me. But there's still the issue that, like, normally you would expect supervised port. That doesn't really make sense. But BusyBox NC will actually default to port 0 if it's not a valid port. So it would connect to us on port 0. Just due to happenstance, we got lucky with a 4-byte command injection. So yeah, we could then do IP tables. We would reroute the destination port 0, which I didn't realize this actually worked, because port 0 is like a mythical thing in networking. But yeah, we would just redirect it to another port, and then yeah, we could just get command execution. Easy peasy. So yeah, that was a fun bug. Claudio also did another really cool Wi-Fi bug, I thought. This one is actually a drive-by that you could do, which was, I think, the coolest part. So, like I was saying earlier, like when it starts to scan for the SSIDs and be like, which one is mine? It would do it with the highlighted commands to the top here. I have config RA0 up, and throw it into a list. So, the output of IW info looks like that, with the ESSID, valid SSID, and so forth. And then it would get further processed because it's like, I want to say which one, what the signal was for each SSID and so forth. And it did it with a really ugly awk, and I don't like awk, so Claudio handled this one. So yeah, it's essentially, long story short, if you had an SSID that was channel, some sort of a string, and then hashtag signal, it would actually pass the validation. And we could get a 16-byte character injection into the best char variable of a script, and that's what the return value of that awk statement is. Boop. And then that specific variable is used in a set statement, and once again, it was just like a really restricted command injection. Like normally we've done command injection tons of times. It's everywhere. You can write scripts to automate finding it. So it's not as interesting a problem, but when you have arbitrary restrictions like this, it gets to be kind of fun, which is why I wanted to mention these bugs in the first place. Also, in combination with the cool attack vector, I guess, because we could just drive by with a certain SSID, and we could inject, do you see the like x/colon BS in the middle there? Claudio did some like sed jankery, and that's actually an infinite loop. So it's just gonna keep jumping to itself. So when you drive by and circle tries to boot, it just gets stuck there. So you could just denial of service every circle that you could broadcast to, and liberate the kids from the tyranny, But yeah, so it gets stuck during booting. Yeah. So now I'm gonna take a quick monster drink, because this is my child. I loved this set of bugs. The cloud routing vulnerability, and I didn't really have it was really hard to classify because it's like, I don't know, and there's no really like good classifying CWE or whatever you want to say. CVSS? No, CWE. Too many acronyms. But yeah, and so like what we ended up doing is that, so like when you have your phone, mom and pop want to monitor the kids, make sure they're, browsing what they need to browse, but they want to do it while they're at work or so forth. How does that actually work? I mean, a lot of this use that feature, but nobody actually thinks about how it's implemented. Sorry, I'm just checking time. And it's funny because like every product home rolls this stuff and they do it in their own way. Some people do it right and some people do it wrong, which is typically the case. In the case of the Disney Circle, they indeed did it wrong. I thought they did it right, but they didn't. So, yeah. And like I sort of hearkened to my high school days in this PowerPoint part. I'm sorry in advance for the quality of the slides. I just thought it was funny. So, that is Pop over there, and those are the kids. And there's a Disney Circle right next to them too. They're inside of a house, if you couldn't tell. So yeah, what ends up happening? Those lightning bolts are how the cloud connects, I guess. That is my artist's interpretation. So dad wants to connect to the kids, to monitor the kids. What happens? Oh, the phone reaches out to remote.matecircle.co. And okay, well that doesn't really make sense. Like you have a router at your home. How does it get through? What happens? How does it know which circle to talk to? How does that authenticate? There's a lot of questions that need to be answered for any given remote communication set up through the cloud. So yeah, we're gonna go through all these points right quick. So the first thing and the most important thing, how do we even speak to the circle, like implementation-wise? How can we talk to a little box inside of my home network from anywhere in the world? Well, there's a beacon. Once again, hearkening back to the attacker's techniques for implementation. Essentially what happened is at a predetermined length of time, a UDP ping message would be sent out by the R client binary? Yeah, I think so. And it's a simple like ping, literally. And it did it over a custom implemented network protocol, blah, blah, blah. And then naturally there is a Pong message in return. But this actually does something really important. I guess it sort of punches a hole through the firewall because, yeah, your firewall typically is going to be like, oh, there's traffic outbound, and then there's traffic inbound. I'm going to let it through, right? How does UDP work otherwise? So this is the hole through the firewall, outbound, inbound, and eventually, once the phone tries to connect to the device, remote.matecircle.co will send a connect message through this pinhole through the firewall. So that's question number one, sort of, but this is what it actually looks like. So. If you'll notice, I believe it, no, it doesn't send out in this one. But yeah, it's just you got a ping and you got a pong. The first 16 bytes after the ping to are actually the MAC address of the device. I cannot recall at the current time what the ID and tag were, but they were not important. And then the pong contains the MAC address of the device also. Boom. So after the connect, then the circle would actually send an SSL outbound connection to the cloud, and essentially the cloud would act as a pipeline in between the phone and the device. These commands would go over the SSL tunnel into the RClient protocol, into the RClient binary, and would talk that custom backdoor protocol. And I call it that for a reason. We actually did find a backdoor. So yeah. That's question number one. How do we talk to the device at home? And like I was saying, it seriously uses an attacker technique for this, because I mean, how many people have used beaconing for what is the graphical Metasploit controller thing? Sorry, Cobalt Strike? Yeah, that thing has a beacon too. Same thing. It just pings outbound. Eventually, you can connect inbound. But yeah, so. The first things that were actually sent over the SSL connection of it, not the UDP, thankfully, was your creds. It just, boop, hey, this is my admin credentials to the device. So like I was saying earlier, how we could we were actually using the SSL man in the middle here to get this data. And that's why it was kind of a big deal, because we could be like, oh, we got root. Yeah. But it was consistent at the bottom. It'd be nicer if I expanded it, but the password consisted of a MAC address hyphen a randomly generated blob hyphen the date of the token creation, which is like, that's a decent password. We couldn't brute force it. It just wasn't feasible to do that just because of how it's generated, thankfully. Oh yeah, sorry. I should just keep right arrowing. So yeah, that's question number 1. UDP beacon to a reverse SSL tunnel. Question number 2. How does it know which home to hit? Like, how does the cloud actually do its quote-unquote routing? We can actually answer the next 2 at the same time, which is kind of funny. So once again, we have our dude. On his Android phone, there was a PKCS12 blob that was base64 encoded, and if you, it was stored inside of a SQLite database inside of the data directory of the phone. It does this upon setup of the device, and it is used for authentication to your device, or from the phone to the device. It's just a CERT. Boop. That arrow shows the connection. I just want you all to know. So this is what it looked like if you actually decoded the blob, because this specific format is a binary format, so you can't just read the certificate out of the file. But yeah, the only thing that was really specific or special was the fact that the SSL attributes of the certificate contained really long stuff. And I'm like, whoa, are they really throwing their passwords and credentials inside of the attributes of a certificate? Because that would be ridiculous. Who would do such a thing? Thankfully, yeah, so you could actually generate, this was a funny one, you could generate any cert you really wanted. Because how your phone generated the certificate, it would actually reach out to their servers with a predetermined set of parameters, which is what that JSON looking stuff up at the top is. And based off of what parameters you provided to their server, you would get a cert with different attributes back. So I may have generated a certificate for their domain, but who knows, you know? But yeah, you couldn't actually generate any certificate you wanted, I guess. There was one restriction in that I believe it was the Circle ID and the Go token were actually linked together. So like one was a UUID of the other, and I didn't know what the hashing algorithm was, so I couldn't spoof it. But anyways, if you sent that post request that is listed at the bottom, you would actually get a certificate with the following attributes. That was actually signed by their certificates too. Yeah, so like I was saying, we could generate a cert for any domain. It would be signed by them, which once, it wasn't actually used for validation though, for other domains, or sorry, for other services, so we couldn't use it for like man-in-the-middling or anything. It had a very specific use. This one, I've got my phone and I want to connect to my device at home. Getting there. And yeah, this made me kind of sad at the time, because I was just like, well, if they do this, there's no way I can really brute force that string, or I can generate a certificate for another device, because each device has a unique MAC address, which is linked to that Go token's UUID, and since I don't know the hashing, I cannot generate a cert for any device, which would let me connect to any device. And that's a lot of assumptions there. I didn't really know, and so there went my plan to brick or root every circle in the world, which was kind of my end goal. But my assumptions were wrong, which is really funny, because like, I think it was so I've got a network proxy that I use, that I wrote, and I can, do SSL man-in-the-middling with it. So I connected to I tried to do a man-in-the-middle from my phone, on the phone side, so from the phone to the cloud, and I used a different certificate than the one that was on the phone, and it still worked. And I'm like, what? It doesn't actually depend on the SSL certificate. So what is it actually using for validation? Like, I could still talk from my phone through my proxy to the device without the right cert. So something's not right there. So I eventually managed to parse it down to the fact that the only thing that really determined which circle and that my requests would go to was that highlighted portion of the request, which was actually the authentication token for the device. It's not the real one. I obviously obfuscated it. But so yeah, the token was used not only for authentication, but for routing. That's like using your password to decide which packets your computer computer, or which computer your packets go to. But yeah, so once again, just due to how that token was generated, like I was saying, MAC address, blob, and then date of creation, we can't brute force that just because of the middle portion. And I'm like, once again, my dreams were dashed. So thankfully, my assumptions were wrong again. It turned out that only those bytes specifically were what determined where my packets went. And so, if you all know things about network devices, they each have a unique MAC address. The first 3 bytes of a MAC address are called the OUID, which is the organizational identifier, which is specific to the circle. And so that is the same for every circle. So that reduces my entropy to 3 bytes. And now, I can just write a script. Oh, yep, sorry, womp womp. Yeah, I could just write a script to iterate over, I mean, it's just 3 bytes of entropy. You can iterate over it. You can write a script, pwn every device in the world because of just due to how it works architecturally. You can connect to it from anywhere. It doesn't matter what sort of firewall is there. So yeah. My slide's going wrong. Oh yeah, and so another thing that I thought was really funny, I thought I'd include really quick, this is the last thing, was the fact that you could just send an unauthenticated request that would send an SMS to the owner of the device. So Claudio had one of these things too, so I just read a script and it's like SMS, SMS, SMS. He was not a happy camper that day. But anyways, yeah. So, once again, all the write-ups are online on our blog. It was a fun project. I guess closing thoughts. What time is it? I could potentially do a demo, maybe? Who wants to see a demo that might work? Okay, cool, yeah. All right, sweet. But yeah, the Disney, I guess, closing thoughts before I attempt this. The Circle people were great. Everything was fixed. They were really responsive and really great people for this, like, working with. They're a really good vendor to have had a patching experience with, I guess that's a way to put it. I even ended up getting, like, some Mickey Mouse stickers or something. I don't know. I think they liked it, I guess. I don't know. Anyways. Yep, once again, Lilith, Talos, cool. All right, let's do this. Do I need to plug in again? Sorry, I like alt-tabbed. I've got my command prompt up here, but I don't see anything up there. Is it gonna do the thing? What? It did the thing. All right, cool. All right, so first things first, in order to get this to work, I actually need a wired connection, so I'm just gonna hook this thing up right quick, because it does have an Ethernet port on it, so we go like, boop. I suppose it was more of a click than a boop. The jokes are not same every presentation. I try to freestyle it, you know, but, so now the circle is on. I should have a new interface, so called E3, so I'm just gonna, oh, apparently I don't. I probably need to put that into my device right quick. 1 second. Removable devices, Apple, USB Ethernet. Boop. All right, cool. So do I have E3 yet? Cool, we have E3. So if I do an IP config just to verify, or IPA, we can see I have E3, my IP address 192.168.0.5. Cool. So essentially, oh, you see traffic up there? So I'm hosting DNS mask, so I'm doing DHCP. I gave it some random IP address. I don't care. That's on the same network. Cool. The main thing is I resolve every DNS address to me because I want all of its traffic to go to me. So, yeah, we're clear. All right. Where do I need to be? I'm going to pull my plug right quick. Sorry. I did not prepare enough. I apologize. All right. I just don't want to show off any of my other directories. Is that soothing enough elevator music for you? Thank you. No, that's not it. I got scared because I thought I was broadcasting again for a second. right, we're here now. It's always fun looking at the dumb shit I named things back in the day. Okay, we're getting plugged back in. So I named the exploit Let It Go because, I don't know, it was a bad Disney pun, but I'm just going to do Python letitgo.py. So essentially what it's doing is just binding to port 80. I might need to re-plug it in. One sec when I think about it. Like I said, this might not work because I didn't try it actually. I should have. I pray to the demo gods. I just thought it'd be more fun from my perspective to try it live. Makes it more exciting. Is it going to do the thing? I don't know. So essentially what this bug is, it's one of the command injections that I thought wasn't really interesting. Oh, are we doing the thing? Ooh. I don't think that's the thing. But so it does a lot of just HTTP traffic. I might have already pwned this one. One second. I apologize. Oh, no, I don't want to do that. Here. All right. I should have tested this. Gosh darn it. The ID RSA. I'm just going to test this right quick. Oh, yeah, okay, I already rooted it. God dang it. So long story short, that's what essentially, it did work a long time ago. But yeah, we just inject into a script that is going to pull firmware, and I just give it we get a command injection. It's easy. I make it reach out to me. I grab a certificate, install it to the Etsy SSH config, and then we can just SSH as root. That was a great demo. Yeah. But anyways, yeah, this is root on a circle. It's an OpenWRT thing. Anyways, questions? Considerations, thoughts, feelings, feedback?